do you define your subnets, how do you define number of hosts, your increment, and exactly how do you create this table of subnets eventually. We're looking at how do you provide time fragmentation. I want to know exactly how do you fragment each type of the datagrams using the allowance of the size to reach the destination, and eventually looking at the volume table over prefix. So that's mainly what I'm going to do today. Hopefully it will be an hour and an hour and a half maximum. I'm not sure we're going to be longer. I'm trying to give you some extra examples today and focus extra on the tutorial as well to see whether you can work it out. Okay, so let's start. IP classes. How many classes do I have? So is it only 3? Oh, I just defined 3 there. So I defined A and B and C. Is there any other classes? Yes. Where are these? Where are these classes? Yes, but I don't know, but yes. Again, when I say classes, what do I mean? So if I would say class A, what does that include? So how do you define class A?
2, 10, 12.
Okay, so it's a range of numbers going from, let's say, 0 towards 1 to 6, for example. I'm not giving you the right range at the moment, but a range defines a class. So in addition to that range, whenever I define a class, I define exactly what kind of that byte is a host or a network byte. So if I would write an IP address, how many bits is an IP address? Let's put that there. Bits. How many bytes? 32, exactly. So there are 4 bytes, 32 bits. So any IP address can look like this. 10, for example, 7, 20, 1, 2, 3, for example. That's your 4 bytes of your IP address. So when I say this is a class A, which byte is a network and which byte is a host? So that's your network, and these are your hosts. Creating a number of approximately a class A will be a 60 million hosts each. That's your class A. So in other words, you have a network, and everything else are the hosts. What are the ranges? Let's just focus on your range of numbers. So it goes from what? 0 to what? Two, five, 5. Okay? So your range of numbers are, so any increment should go from 0 to 255. If you go past the 255, what does that mean? You go to the next byte. So that's your increment. That's how you move from byte to byte. Just keep that in mind. When I'm going to do subnetting, you need to know this information. Okay? So we define class A as the range of numbers defining the class. Then class C is, then we have class B, and again have a different range from, for example, 127 to 223. I'll give you the exact number of the ranges. And then eventually you'll have a class C will be the lowest part of the network. So class B, how many bytes are the actual network and how many bytes are the actual hosts? So if I would say this is a class 19, let's call it 170, 70, 1, 1. How many bytes are your network and how many bytes are your hosts? So 16 exactly. So that's the number of 2 network and then 2 host partitions. So when you say 16, what does that mean? For that who said 16. So where is that 16? So how many then is this? How many bits? So 16 is reflecting what? He said 16. Half of it. So which are they? The network or the hosts?
Network.
The network. So exactly, if I would say the number here, that's your masking number. So if I would put 8, that means these are your 8 bits of the network portion. So when I say 8, I'm dealing with bits, by the way. I'm not dealing with decimal numbers. So when I say 8, that means your default masking at the moment will be what? 1, 2, 3, 4, 5, 6, 7, 8 ones, and the rest are zeros. In decimal, that's 255. If you open your actual browser, your setting and your machine, and you want to find the default masking for your class, if it's a class A, then this will be your default mask. Let's look at a class B then. So we said the number here is indicating your mask number. Okay? So these are the pure classes. This is not classes in the domain. That's a pure class of having a portion, a full portion of a network and a full portion of a host. So if I would say class B then, and I will indicate that someone said 16, that means the number of ones indicating the network portion rather than the host. So that's 8 ones in your first part and 8 ones in your second byte, creating a 16. And eventually ending up with zeros for the next host. So ones reflects your network part. Meanwhile, 0 reflects your host. That's what I want you to understand for the first class. Okay? Then tell me, what about class C now? So if I would say, let's focus now on class C. How many network portions do I have from class C? So, how many? 3. How many is that? 24? So that's 8 ones for the first one, 8 ones for the second byte, 8 for the third, and eventually zeros for the fourth. So it ends up with that's network portion, network portion, network portion. That's the final part of only host. That's why the numbers are very low in here. The numbers of the moment with the class C is about 254 hosts only. Because everything else is a network part. So you're defining the other class as a network, rather than the only part of the host is this one. And that's why you have your local internet protocols, i.e. your IP numbers, are mainly the C classes within your homes, because they are a small portion of the network. Meanwhile, if you go now to the university one, if I check IP config, I'll have 10 in the beginning, therefore it's a class A. It's a big company, a big university, requires high numbers of IP addresses. Simple as that. So these are your classes. This is how defined. Increase the number of network will reduce the number of hosts. Simple as that. That's your logic. Having lower portion of the network with a higher number of hosts increase the number of users. So that's your IP version 4, by the way. So a network of 64 hosts is unmanageable. So if I would say class B have approximately 64K, how do I control this? How do you control 64? You don't, exactly. You ignore it. Imagine you have a table. You have a table in your machine, a routing table with 64K entries. How do you manage it? That's why we need a subnetting. That's why we define subnetting. So each subnet will have a number of users. So rather than defining every subnet in the network, you just look at the subnet you need to contact mainly, or the subnet you are sitting in. You want to contact your mate, your colleague, which is sitting in the same lab. You don't need to know all the university subnets. You just want to know the subnet in that lab. Simple as that. So they created subnets to save that, to save you the match of going through all the network and all the subnets. In other words, categorizing them into small groups and categories. That causes problems as well. It solves issues, but causes many problems. And we'll come to it in a moment. So can no longer rely on a class because the classes are very big compared to the actual subnets. But that created other issues. Routing the switch is required to have an identification. Therefore, the which bytes are network portion, we define that, which is the portion of the byte, the portion of the network, in a sense. So again, I'm here trying to show you exactly the portion of your network, which is defined by the number of ones. If it's a hexadecimal, it's number of Fs. If it's an actual decimal, it's 255. If it's a bits, it's just ones. This is how you define your masking, the actual network parts. Zeros are actual hosts. Looking at this example, allowing sites to subdivide class B addresses into subnets, this default is actually defining, when I say a network portion, I'm defining exactly the location. When I say only a first part is a network, therefore I'm defining, for example, DMU. If I want to make it in more details, that means DMU and CSE. Then I want to define it in more details. I want to say gateway house in the 5th floor. This is your actual portion of the network. You're defining exactly where is the subnet. And whenever you reach that, in the end, you reach the gateway house in the 5th floor. Now you need to know exactly where is the host. And therefore you want to send the information that will be the final part. Okay? slide here, I'm here trying to define a table to know exactly how do I have a value of a bits in a byte. So let's take a byte and look at it in full details. So I'll give you a set of addresses. Let's focus on one of those addresses and look at each byte individually. So let's say we have a byte here, consists of number of ones. What does that mean in decimal? So if I would say these are my 8 bits, 3, 4, 5, 6, that's 4, 4. Each one of them to be transferred into a decimal value, you have a table looking at to it. Each one of them is reflected by a 2 to the power of a value. So the first bit is a 2 to the power 0, which gives you a number of 1. So the first bit in your byte, its actual value is 1. Second bit, 2 to the power of 1. And that's what? That's 2. That's the second value of the second bit. Looking at the third bit, that's 2 to the power of 2. That will give you 4. So the third bit in the actual byte, the value of it is 4. Let's continue with this. 2 to the power of 3, I will give you 8. 2 to the power of 4, 16. 2 to the power of 5, that's 32. 2 to the power of 6, that's 64. And finally 2 to the power of 7, that's 128. That's the number of each value of each bit in your bytes. Okay? And that will be needed at one stage when I'm doing subnetting. Usually we have a network address and we subnet it with a mask. And that will give you something called a network prefix. I don't want you to worry about it. My main concern is to understand this table and then how do you actually work on your subnetting. Okay? At the moment, is this clear? Straightforward. Each bit has a value, you know that. So if I would say, what's the value of those 3 bits? So if I have an address looking like that, 1, 1, 1, 0, 0, 3, 4, 5. What's the value in decimal?
2.
So that's, in other words, that's 128 plus 64 plus 32. What gives you something? I think it's 224. So this, if I was trying to transfer this into a decimal, i.e. bits into decimal, that would be the value. I'm looking at this table. I'm trying to have an indication of how to create the decimal number. Okay? Any questions? That should be straightforward. Good. If I would say IP config at the moment, that's what we look at. Exactly, you'll have a Windows IP. This is a Windows IP configuration. I've opened a doors that are sent IP config. And that will give you details of your physical address, your IP version 4, your IP version 6, your mask number, your actual default gateway, and therefore. So if I would look at this example, the IP address at the moment is 146.227.54.108. The default mask is 255.255.2550. What class is this?
Class C.
C, exactly. So the 3 first portions of the actual address is a network host. The final portion only is the host system. What are the issues with IP version 4? And that's why we enter up into the classes into doing. First of all, the numbers were being reserved by, I said, I think at the beginning of networking, the network lectures, we said mainly companies came in and reserved large number of Class A addresses for their own use. And they are at the moment sitting somewhere but not being used by anyone. They will use them whenever they are required to deliver to the number of users. So for example, this university, DMU, have both X number of IP addresses. How many users do we have? Let's just give me a number, 2,000 users. Let's say 2,000 users, okay? So just, it's not impossible, it's much higher than that. How many DMU did both? About 10,000? So just like look at the numbers. They never buy IP address to fit only the users. They buy extra because they will say we'll have more students eventually and we increase the numbers. So every year we buy extra numbers but the numbers might not live to that standard. So we are wasting IP addresses. I don't give away for that, but that's a reality. Look at that big companies, IBM, Apple, Aprico. They buy even larger numbers, and they are sitting somewhere no one is using it. So that's why we ended up with exhaustion of the actual IP addresses. No one can have access to it because they are sold out, put it that way. So we needed to have some sort. Let's explain the full problems. So the exhaustion of addresses, largely due to wastage from allocation of Class B addresses, and that's what Class B is, about 65,000 IP addresses. Poor routability. The IP version 4 network address bears no relation to physical locations. That's why we needed the MAC addresses. So there was an issue with the IP addresses to be located to as a physical address. The routability problems created large number of tables. So imagine you have a big table in your machine, about 2,000 users. How do you use that table? That will create overhead, that will create issues, that will create so much problems with the routability. When I say routability, if I want to forward a packet, imagine we are dealing with bits, so every address will be forwarded. It's a 32 bits of numbers, you need to match it with your table. So let's assume this is your table for a minute. And these are like 4 bits each, but each one of those is like 11010110 and 0110, 32 bits, and every packet you arrive, you have a big table of those numbers, and you start matching a prefix. Where do I send this information? So your routing table is really big. And I'll show you exactly how prefixing is working in the next slides. Final issue, there is a limited support for multicast addressing. Because mainly most of them is being reserved, and whenever you create a subnet, a big subnet requires only one multicast address. So if I would have a subnet of 64,000 users, how many multicasts do I have? Just one. If I would have a network with 64,000 users, I'll have only one multicast. That's the FFFF1, the one of the ones. So we needed to have some sort of controlling this network rather than leaving it open. That's why you have this global and local IP addresses as well. It's a sort of trying to control it better way. So again, there are issues not being solved. There are still issues with IP version 4. And some say, okay, but where is IP version 6? Where is that? Why don't we not use IP version 6? Someone can tell me, why don't we not just use IP version 6 instead of IP version 4? Again, IP version 6, yes please.
It would be expensive to replace with the IP addresses.
So when I say I'm going to use IP version 6, what exactly I'm changing? I'm changing my NIC card, or at least updating it. I'm changing the software, I'm updating my router, and I'm changing all the software related to all the machines in my company. So again, to do that transition needs time. So it is eventually the final solution of saving that issue. But as a temporary solution, we need to have something else to deal with the temporary part of classifying those subnetting. That's why we have this classless inter-domain. Okay, let's look at the other issues. Inflexible header. All IP packets carry the same header overhead, even though very few packets may utilize features. What's that? What do you think that is? Each one have a set of features, each IP address. So if I would say you're trying to send information, you're trying to retrieve a YouTube video, what are you looking for? Mainly. Do you want it to be slow but with high quality, or mainly you want to see the video, the movie in the less seconds? What do you look for? Speed or quality at the moment? If you want to sacrifice on something eventually, what do you take? Do you want to wait 2 days for watch a movie, or do you want to do the lower quality for that's 2 minutes? Speed mainly. So your requirements at the moment will be speed. Another person will come in and say, look, I want this HD 4K one to watch it fully. I want to wait. I don't care. I just want to have the quality. So eventually, you sacrifice speed upon quality. So what I'm saying here, each user has its own requirements and criteria. Each one of those criteria will have a heavy weight on the IP packet, because you're asking it to deliver something that's not available there. So what I'm saying is, look, I want a low speed. I don't care about the quality. The IP header file will still carry the quality of service available, rather you use it or not. They don't consider that. So it will still be overhead of quality, even if you're not using it. So what I'm saying is, you watch a YouTube movie, but you lower the quality from a HD one to a 240. You still receive that quality of service within your packet, even if you're not using it. So you're still wasting and you're still creating overhead. You know what I mean? So how do you solve that? Again, we need to have some sort of a solution. So ability to carry quality of service information is limited, or at least it will be affected by your requirements. These problems addressed are not new, therefore they produce the IP version 6, but it will take many years to implement fully. So we have this temporary solution by this classless inter-domain or classless IP domain routing. What's this? So IP version 4 address classes turned out to be a bad idea. 1. Unused host range in class A addresses. 2. Exhausted class B and full address space. Class C addresses is too small to be attractive to users because you only have 256. And the size of the routing table becomes unmanageable. It's increasing day after day. IP version 6 will take years to implement, so we need a temporary fix, and that may change the new last IP address given in the Europe. And the last IP is given to the Europe eventually. So now the last IP address of version 4 is delivered to the Europe and all Europe. And that's it. There's no IP version 4. That's it. We don't have any version 4 available. Now we're using either the new version 6, either an old version 4 is available at the moment. So you are a member within a BT company. You change from BT to Virgin. You return the IP address. You don't keep it. That belongs to the provider eventually. You're not using something new. Okay? Subnet maps are traditionally operate in a bytes boundaries. So when I say classes, each class cannot be a middle fix. So when I say class A, it's mainly that portion is full either to be host or a network. It cannot be both. If I would say this is a host, it should be zeros. If I say network, it should be ones. There's no way around it. That's the traditional classes. The classless interdomain came in to change that principle, saying that, okay, wait a minute. Rather than keeping that full network portion, let's divide it into set of portion of networks and set for hosts. How will that work? I'll show you in a minute. So the classless interdomain. Why not let the subnet mask contain any number of bits? So in other words, you have a subnet having numbers of 1 and zeros, creating set of subnets and set of users inside that subnet. But how is that possible? That's what will come to the question. So therefore, that will allocate just as many addresses as the site requires. So now I'm controlling. I'm trying to control. I have like 10 users. I want to give 10 users only those addresses. I don't want to create 20 and only give 10 and waste 10. Okay? So then allocate just as many addresses site required by aggregating class C addresses, subdividing unused class A addresses as well. And this is what we call classless IP domain routing. Quicker to implement than IP version 6 because we only need to fix the routers to support this, not the full system. What information are required? This is important. Information required to make this work is 1. If I'm doing subnetting, how many subnets will a subnet mask provide? That's the first question. Second question, what are the subnet addresses? So when I'm defining this, what are the subnet addresses? You need to have those addresses available. Because each portion is being divided into set of subnets, i.e. set of networks. Each one of those networks will have a local address, will have a full definition of that subnet. What are their broadcast addresses? We said main issues within class B, you have 64,000 users, but we have only multicasts, a 1 for all of them. But with subnetting, each subnet will have its own broadcast address. So you need to know the broadcast address for that subnet. How many hosts will be available for each subnet as well? So you need to know that. So how many created subnets, how many users for each subnet are available? You need to know that as well. And what are the ranges of addresses for the host in each subnet? It sounds like so many questions, but there are 3 simple steps to know the information. Are you sure? So let's look at this IP address masked by a CIDR. Okay? And let's divide it and see what's happened here. So let's consider this IP address. Can you all see this? That's 1, 2, 9. 1, 6, 8, 10, 27. What's 27? No, 0. 0 masked by 27. What did we say this number is? The mask. So what are the mask? A number of what? Zeros or ones? Ones. So how many ones I have? I have, that's 8, 3, 4, 5, 6, 7, 8, 16. Let's delete that part. $16, 24, and that will leave us with 25, 6, 7, and that will leave us with how many zeros left? So wait a minute now. Where is the network portion? Give me. Is the first one network or a host? Because it's number of ones. Second portion. Third. Fourth. Both. So that one we call it something called interesting byte. So interesting byte, what does that mean? That means it has a both. It has your hosts plus your network.
I thought you said you decided one or the other.
Sorry?
I thought you said you decided one or the other.
No, on the contrast, the class, the default one, it should be either one or the other. This came into operation to divide the one that being set as a user host into number of subnets and hosts. So you're saving more users and creating more hosts, more subnets and more hosts inside that byte. So how would that work? How would you create now the subnet? How do you know number of subnets, number of hosts? How do you know the range? How do you increment? You need to know these information. So what I'm saying is for class C, traditionally, these are a network, then you'll have a host, traditionally. Now, we've used CIDR to make this into hosts and network. Note the 27 means it is the 4 byte, which is the interesting byte. The 4th byte is your interesting byte. So the subnet mask of this will be what I showed you on the actual board. So let's now make our focus and attention on this interesting byte, because from this interesting byte, I'm going to know exactly what's my subnet, how many hosts do I have, what's my increment, how I'm going to create my networks eventually. So how many ones do I have? So these are your network portions, is that right? So these are your subnets. The formula says, we define a formula says 2 to the power of the ones, that's 3, will give you a number of your subnets. How many is that? So now you have 8 subnets. How did I know that? That's 2 to the power of ones. So the formula here is 2 to the power of ones. 2 to the power of n is your ones. Is that clear, everyone?
Can you go over that one more time? Your number one.
So here, what I'm going to do, I'm going to do 2 to the power of n. That's 2 to the power of n. What's n? N equal the ones inside your interesting byte.
Oh, okay.
I'm just focusing on this byte. Okay? The 2 to the power of n, and n is your number of one inside that byte. So how many subnets do I have? I have 8 subnets, because 2 to the power of 3 is 8. If I have, for example, 4 ones, how many subnets do I have? 16. That's 2 to the power of 4. Yes, by all means, plus 16. Okay? That's how you define your subnets. Okay, we understand that. So how many users do I have? What's the formula? What do you think? 2 to the power of 5, exactly. So now you know the zeros are reflecting what? Your hosts. So the number of hosts is 2 to the power of x. X equals number of zeros in your interesting byte. I doubt anyone can see that, so I'm going to let's delete this unit space. So that's the first part. The host will be 2 to the power of x. That's not the full of it. It's minus 2 equal number of your hosts. Question, why 2? Why minus 2?
For local and broadcast.
For broadcast and what I'm defining, I'm reserving 2 addresses. One of them is for broadcast, exactly. I want to broadcast in that subnet, so I reserve the ones. The actual address of the subnet. You cannot give that address to anyone. It's the address of the subnet itself. So, for other words, the subnet will have an address as well, and you need a broadcast. So you need to reserve 2 for your broadcasting or multicasting, and for your address of the subnet itself. So, give me the formula. That's 2 to the power of 5 minus 2. What's that? Yeah. So you have 30 users in each host. How many subnets? I have 8 subnets. Each subnet carry how many? 30 users. 2 reserved, 1 as an address for the subnet, the second as a broadcast for that subnet. Okay, so now we define those 2. How do I know the differences between each subnet? I need to know something called increment. So what's the increment? There's a formula for increment using the table I've drawn in a second ago. I'm going back to the main page. Look at the value of the bytes. Okay? Let's return to that point. My formula says my increment, sorry.
Is that 30 users on one?
30 users on one subnet. So each subnet will have 30 users. Now I need to understand my increment. So how do I work my increments? My increment is 200, 5, 65, 56, 256 minus my byte value of the ones. So that's 128, 64, 32. The actual summation of those values will be 2 to 4. That will give me 32. That's your increment. So the address between each subnet is the increment. So if I would have an address here as 192, 192, 127, let's say that's it, and 0, 0, let's put it that way. And I measured here 27. So the increment means the next subnet should have, and this is my interested byte, the next subnet should be 32. So in other words, that would be 192, 127, 0, 32. That's your first subnet, and that's your second subnet. What's your third subnet? Incremented by 32. What's the value? 64. What's your fourth subnet? Incremented by 32, and so on. I'm going to create a full table, but I just wanted to show you exactly how this works. Okay, the increment itself. Now I'm going to show you exactly full table of the full details of each subnet and each details of the broadcast and the information. Okay, let's jump. Okay, let's create it here first, and I'll jump eventually. So the same question. Okay, we're not going to change the question. The same question, and I want you to work it out based on the details we just explained. So eventually I'll ask you to create your subnets, your local hosts. I want to know the hosts eventually, your first, the broadcast, and the last address. So how would I draw that? Let's put it this way. I will say your subnets. Okay. I will say your first address. Your last address, and then you'll have your broadcast for each subnet. So what's your first subnet? We are using this address 192.172.10.0, and I sent here 27. We've worked out all the details in here. So I'm just going to explain. How many subnets do we have? We said we have 8. So eventually I'll have 8 subnets. What's your number of users in each subnet? You have 30 users, 2 reserved. And then what's your increment is 32, okay? So these are your information you're going to work with. First address in the first subnet, what is it? So now I want to know, not the first address, give me the subnet itself. So what I'm going to do here, I'm going to do subnet, first subnet. What's the address here? Okay, tell me the full address. What is it? So that's 192.
168.
192. 168.
10.
10.
0.
10. 0. Exactly. That's your what? What's that? That's your subnet address. That's the one reserved, not the first one. That's your subnet address. That's not the first address. That's the subnet address. The two that are reserved, what are they? The subnet address and the broadcast address. These are reserved. From here, 192, 172, 10, 0, 20. So I gave you 27 as a mask, and you work out the details. And then you saw defining each subnet. So that's your first subnet. What's your second subnet? Before I go to details, let's do 3 subnets and move on. What's your second subnet? What do you do? Increment. So what's the value? That's 192, 168. What is it? 68, 178? Make it worse. Try yourself. 1, 9, 2, 1, 7, 2, 10, 0. Second, 1, 9, 2, 1, 7, 2, 10. Third subnet. Let's work it this way. And I'll stop at the third and I'll fill the details. What's the third subnet?
192. 172. 10. 64.
Exactly. What did you do? He incremented 32 to the actual value of the final bytes.
Is the increment not just 256 divided by n subnets?
Yeah, you cut it out, but
Yeah.
I'll do that when everyone expert everything. I'll give you other option of doing it. So at the moment, what's your first address and your first subnet? Tell me. First address and the first subnet. 192, 172, 10. You just look at the interesting byte, by the way. I'm not doing anything. I'm just changing my details in my interesting bytes. This is what was being incremented because that's the interesting byte that's been involved in that subnetting. Not the full address. That's only your actual interesting byte. The one which has networks, i.e. subnets, and the ones which have number of hosts. So exactly tell me, how many do I have? What's your first user in here? One. What's your broadcast address? 31, exactly. That's 192, 172, 10, 31. Why is it not 32? Because if I say 32, that means I'm entering my second subnet. I'm not doing that. I need to leave that in isolation to the first subnet. That's the whole reason of it. What's your last address?
So why not first address 0?
I'll just explain. What's your last address? Third. That's it. 10, 30. What's your question?
Why isn't the first address?
Why is it not the first address 0? What's your subnet address? How would I differ between those two? That's your subnet address. That's your first address. Questions before I continue with the second and third one? Is it clear? Questions?
Can you explain the formula of increment again?
I'll do the increment because I'm going to do another question afterwards. Okay? But at the moment, let's just fill out the details here. Okay? So what is first address in your second subnet? First address, 33. Exactly. 192, 172, 10, 33. What's your broadcast address? 63. What's your last address? How many subnets do I have? 8. So this will continue until you increment 32, you reach 255. Okay? That's your last broadcast address. The last address will be 254, and the first address will depend on the subnetting. Will be 225. I'm going to do another example to make it clearer. So I'm going to choose the same class, because if I change the class, these numbers change as well. So I'm just going to fix with the same, as the interested byte is the final one. When the interested byte becomes the second or the third, there are differences because your range are from 0 to 255. So I'll explain that later. I don't want to confuse you, if that makes sense. But before I start the next example, what other things are not clear? So the increments, you want me to explain the increments? What else? So what other things I'm looking for? Main thing, subnets. How many subnets? Where is that depending on what? On your interesting bytes. Okay? Hosts, how many is that? Depending on your zeros inside that interesting bytes. Eventually, your increment is a formula of 256 minus the number of bytes of the ones. That's it. Let's do another example and make things clear. Let's go back here. Let's start with this address. 192.168.0.0. So let's say 28. Okay? What's that number? So first of all, what's this number? That's your IP address. Usually class C is network hosts. Usually. The mask will define that. Yeah.
So big B because it's 2 zeros.
No, doesn't. Maybe it's just starting with a 0. The range of the first byte define the class, not the zeros inside the actual address. Be careful. So let's define now your number of your subnet mask. How do I do a subnet? We said we look at the number of ones inside that address. So 28 means 28 ones out of the 32. So that's 8 ones in the first byte, 8 in the second, that's 16, 8 in the third. How many ones? There are 24s, 24, 25, 26, 27, 28. How many bits do I have left? 4. And these are what?
Host.
What's the first portion? That's the network. What's that? That's the one we need to look at. That's your interesting byte. Details will be extracted from this byte. Okay? What is your subnet? So if I say, give me a number of subnets, someone. What did you do? 2 to the power of 1s, which is 4, which equals 16. That is 16 subnets. Okay? Any questions at the moment? What's the number of hosts? Give me the formula. 2 to the power of zeros, that's 4, minus 2 will give you for each subnet.
Is it always minus 2?
Yes. Why?
Broadcast and
Why? Because of the broadcast and the subnets itself. So we said we need to reserve 2 addresses. One for the actual broadcast, the other for the subnet itself. That's it. That's what I'm doing. That's why I'm minus 2. These are reserved. If you don't have a subnet address, you cannot define an address in the subnet. That's what it is. What's your, I don't want to know your address, but what's your house number eventually? You need to have a number. You're not giving that to anyone else because it has to be known. So that's the same with the subnet. You need to define something to give an identification to an actual subnet, and that's a number. The other identification is to send information to everyone, which we reserved another one. We call it a broadcast. That's it. Okay, final thing is your increment. I'll do yours later. But what's the formula? And I'll explain at the moment. It should be easier because now you know the number of values in the bytes, and that's 1 to 8 until you reach 1. Is that right? You want me to do that table again? Let's do it here. How many bits do I have? I have 8 bits inside my bytes. 1, 2, 3, 4, 5, 6, 7, 8. Each one of them will have a value in bytes, in decimal eventually. So that will be 2 to the 0 until 2 to the power of 7. And that's 1, 2 to the 2 to the power of 1, 2, 3, 4, 5, 6. Okay? That's 1, 2, 4, 8, 16, 32, 64, 1, 2, 8. How many 4s do I have here? I have 4 starting from the leftmost side. So that's 1 to 8. So your formula says 2, 5, 6 minus. That's what we're going to do. 1, 2, 8 plus 64 plus 32 plus 16. So it'll tell me what's that. You'll end up with, yeah, eventually will be 16 here, but I want to give a number here. 256 minus. That's what your increment. Any questions? I'll do the table and we'll have a break. But I want you to be understanding what's happening. Let's try to write this statement. That's already works. So I'm not going to do the 16, and even if in the example I ask you to do something, I'll give you a range. Imagine if you have like 32 subnets, are you going to do 32? I'll ask you to do 3 or 4. I'll give you something lower. Depends. So what's your address at the moment? Your address, let's write it down here, is 192.168.0.0, masked by 28. Okay? To create, I'll ask you to create your subnet. I need to know the subnet address. I need to know your first address, last address, and then the broadcast address. These are the information I need. So, let's create a table. So, first subnet, what's that? So that would be 192.168.0.0. What's your first address? That's your first address. This is your last address. And this is your broadcast. And that's your subnet. Okay? Let's define 2. So I make things easier to myself. I define the subnets first. That's the easy way to do it. So you keep track of all the information required. So I would say, okay, first is 0. I incremented by 16. So I'll say my second subnet will be 16. I'll increment the second one by a 16 as well. So that will be 32. And I'll continue with my question. To make things easier, so I keep track, I control the actual subnets. So I know where to stop. Where's the last one, and where's my broadcast, and where's my first. So I define second. What I do, I define the broadcast. Because it's the one value, the one digit before the actual broadcast. And that will be what's in here? 15. 0, 15. That's the broadcast. So eventually now the first and the last should be, is a logical. First one is 1. Last one, 40. It's now better at least. Is it clear? Okay, so let's have a break, 10 minutes, and then I'll continue the lecture.